Welcome back to this CENGAGE CRACKER channel. In my previous video, I actually talk about importance of JEE. So please try to watch that. Today we are officially starting mechanics and we are going to crack kinematics 1 together. In this video, we will break down the core concept so that we can solve the problems step by step easily. So yeah, let's get started together. And let me move out on the introduction page. And before learning the concept, try to understand these topics. These are the topics: introduction, trajectory, motion, frame of reference, and trajectory and equation, displacement and distance, velocity and speed, acceleration. Sorry, this is translatory motion. Now let us move on to the introduction. First of all, we must know what is meant by kinematics. It is nothing but it is the study of motion of an object and ignoring the agent causing the motion, which means that we don't bother about the external force. For example, motion of rocket, we don't bother about the thrust which is given by the rocket. And yeah, usually the nature of motion of body in general is high complicated, being composed of translatory, rotatory, and vibrations and etc. is too complex. So to simplify the complex nature of the motion, a body can be treated as a particle, which means a huge rocket we will be considering it as a particle, and it is possible only dimensions of motion are too large compared to its size. I trust you could understand this, which means if you take a rocket, if I consider it as a particle and it moves the length of its distance, it is not possible, right? That's what I come to say here. And here I mention particle, which means object without dimension, that is having no length, breadth or thickness. Even though there is no actually existing in nature, still the smaller the dimension of object. As I mentioned in this diagram, see, when size is negligible, body can be considered as a particle. And also this whole cube is considered to be a single particle. And that's all about it. Let me move to next slide. Now it's motion and reference. To be perfect in this kinematics, you must know these key terms. And so yeah, what is translatory motion? When a body moves in such a way that linear distance covered by each particle of body in same duration, then the motion is said to be translatory or translation motion. And it can also be any of two type, curvilinear or rectilinear. And here it is important that body does not change its orientation. That is too important. Try to understand the concept. So yeah, that's all about it. And let me teach you frame of reference. What is it? It is actually nice concept. In kinematics, we access the position, displacement, velocity and acceleration of a particle, and we will take the observer as a reference. And it is a origin of coordinate system. Sorry, let me teach you clearly. The observer is to be at the origin of the coordinate system, while the place where the observer, I mean reference point, is placed fixed is known as a reference point. To be clear, let me give you an example. In the figure below, two observers are observing the suitcase which is placed on moving trolley, and observer 1 is on the trolley and observer 2 is on the ground. Observer who is observing the suitcase will say some other thing. They will not say same thing. Yeah, right. Because observer 2 is on ground, he will say the suitcase is moving, but observer 2 is on trolley where suitcase is also in the trolley, so they observer 1 will say suitcase is not moving. So they both options are different, but They both are correct. Both observers are looking at the same object, but they have different observations about the state of suitcase, and no one will be wrong because they are observing the object from different frame of reference. That's a matter. So what I'm saying now, nothing in the world or in universe is at absolute rest. Even sun is also moving with other frame. Yeah, that's a matter, and there is nothing special on frame of reference, but it is too important. Let me move to next slide. And this slide tells you about trajectory. The path followed by a point object during its motion is called a trajectory. For example, if rocket is launched, it moves to the space. That path is known as a trajectory. Yeah, that's it. And key points: trajectory shows the actual path of a moving object, and it depends on the motion of object. And it is important, different motion have different trajectories. For example, straight line motion will have a trajectory in is a straight line. Curved line motion will have curved trajectory, and circular motion will have a circular trajectory. In real life example, we may give many things: football, kicking a football, moving of car, moving of aeroplane, and many things. That's all about it. Let me move to next slide. This slide tells you about displacement and distance. From here the fire begins. First of all, you must know what is difference between displacement and distance. Displacement is a vector quantity, distance is a scalar quantity, and displacement is nothing but its magnitude is equal to shortest distance between initial point and final point. See, it is very easy, displacement. Let me say one example to be clear. You are in a park, and the perimeter of the park and diameter of the park are paths. I mean path. And the entry and exit are in opposite directions. You are moving in a curved path, that is known as distance. If you are moving through the diameter, that is known as a displacement. Now I trust you will be clear on this topic. In both cases, initial point and final point would be same, but the length would be differ. And the distance is total length of actual path traveled. That is a semicircular path. Note very carefully, displacement can be 0, whereas distance cannot be 0. And it is represented as d, and distance is represented as s. Distance is a change in path length. Sorry, I made a slight mistake here. Distance is not a change in path. Displacement is a change in path. So slight correction you must do. Don't worry about this. Please change it on your own notes. And formula for distance is this, and don't worry about this symbol. This symbol is known as an integration, and you will study this about study this on your 12th max. And this is known as sigma, the summation. And your school teachers will be teaching this clearly. If not, you really require, you post on comment section, I'll be teaching you that clearly. And in this chapter we will completely see about one dimension only. Note, to calculate some questions you need this. Motion in one dimension will discuss about the motion along the straight line. In such case, displacement in one direction along the line is assigned a positive value, while the displacement in the opposite direction is assigned a negative value. I am sure in your any of your entrance exam, this would be one of the question. I actually attended many question. I mean, many of the entrance exams. In each exam, they actually asked from this topic. So that I'm more specifying this. So that is too important. Try to understand the concept. Let us be clear with solving this two example. Yeah, example one, motion in positive direction. Let us consider that a man is moving along the east west direction, and that positive sign is used to denote the direction due east. If the man moving from x1 minus 100 meter to x2 plus 400 meter, then the displacement is what here they are asking means displacement. So be careful. We know the formula. Displacement is change in uh, path length. As I said here, change this formula as displacement. This one is wrong. Yeah, we are going to use that formula. See, we know that x2 is minus plus 400 as here I mentioned, and x1 is minus of minus 100. So be clear with this concept. I mentioned that here man is moving toward east because x1 moves minus 100 meter, which means from this position he traveled left side. Left side means west side, opposite of east. So after reaching x1 he moved to right side. So now he at last he will be moving to east side. So motion in a negative direction, let us see. If instead of man moves from x1 200 meter to x2 minus 300 meter, then also same x2 minus x1 minus 300 meter minus 200 meter, which is equal to 500 meter. uh, See this red color arrow as a final direction, because here I mentioned east, that is actually west. On cut copy paste I made it a small of mistake, don't take it as a serious thing. And that's all about it. This let me move to next slide. Now it's speed and velocity. In younger age we all must say speed and velocity are actually same thing, but that's not correct. If you all guys know what is displacement, then I'm sure you are very easy to learn the speed and velocity. Speed is a scalar quantity and it tells how fast an object is moving, and velocity is a vector quantity, it tells how fast an object is moving and in which direction. And speed is actually divided in two cases: average speed and instantaneous speed. Average speed is nothing but it is a total distance covered divided by total time taken. See the formula and be thorough on this formula, and try to see this diagram clearly so that you will understand what is meant by average speed. And instantaneous speed is nothing but instantaneous speed is a speed of an object at particular instant of time, and it is the limit of average speed as the limit interval approaches zero. Better you try to understand this formula, because that is too important than this instantaneous speed concept. But I will say, what is instantaneous speed? It is a speed at instant, at a particular instant. For example, within 3 seconds you're at which speed? If we ask means, to find that we will use this instantaneous speed. That is actually very important in our real life. Try to understand and see this diagram to be clear, to be more clear. And let us see what is meant by velocity. And again, it is also actually divided into two cases: average velocity and instantaneous velocity. And average velocity is total displacement divided by a total time taken. And you can see this box, this is a formula. And see this diagram, so you will be so clear. Instantaneous velocity, also velocity at particular instant. As same, see this formula to, so that you will be so clear and see the diagram, and that's a point. And try to understand the difference between speed and velocity so that you can also use it in your CBSE. Speed has only magnitude, always positive or zero, depend on total distance and no directions. Whereas velocity, it has both magnitude and direction, can be positive, negative, even zero. Depend on displacement, has directions. Yeah. And important point, speed can never be zero, but velocity can be positive, negative, or even zero. If displacement is zero, average velocity is also. As numerator becomes zero, then the total value will be zero. That's a matter. Unless no motion. Yeah, unless there is no motion, this condition will be satisfied. In speed, if distance is zero, then the speed would be zero. In a given time, the magnitude of average velocity is always less than or equal to the average speed. And final conclusion is that speed tells how fast, velocity tell how fast and in which direction. To know the direction, we will find the velocity, and to know the fast, we can find both velocity and speed. And let me move to the next slide. Yeah, it is going to be our last topic, that is acceleration. And acceleration is nothing but change in velocity with time. And previously I forgot to say that velocity is also nothing but change in displacement with time. So you can also say this acceleration as change in distance square by time. So try to understand this carefully, because this is too important till your final year of college and so on also. There is many things to say about acceleration. Acceleration is a vector quantity and depends how quick the velocity of an object change and in which direction. And SI unit of speed and velocity is meter per second, whereas SI unit of acceleration is meter per second square. And if you need a derivation of this SI unit, feel free to comment in YouTube. I will be clearing it to you personally. And if possible, join in my WhatsApp community so that all can interact and solve the questions, and let us all together crack JEE. uh, there is three type of acceleration: positive acceleration, negative acceleration, zero acceleration. If velocity increases with time, then acceleration would be in positive, and if velocity decreases with time, then acceleration is zero. If velocity remains constant, then acceleration is zero. You can say why, because acceleration is change in velocity by time. If v1 and v2 are same, then 0 by any time, then answer would be 0, no. So that's a matter. And also you can say it as many things. So here are many useful equations. V equal to u plus ATS is equal to ut plus half AT square. These are actually law which I will derive you in further classes, so no one to worry about that. Acceleration is positive if velocity increases in positive direction, and negative in decreasing direction, and zero if velocity remains constant. And real life examples are car speed up has positive acceleration, car apply brakes has negative acceleration, and free fall ball has acceleration due to gravity. Gravity are actually a huge chapter. Let us read it later. And remember this, no change in velocity means acceleration is zero. And don't forget to subscribe and join our journey to crack JEE. Let me move on to next slide. Oh yeah, it's thank you slide. And wait, And don't forget to follow the channel CENGAGE CRACKER on WhatsApp and even YouTube. Thank you.